Welcome to lecture 15, which is on energy interaction with the atmosphere and earth surface. So in this lecture we will cover when this electromagnetic energy is travelling from source to the object, what are the different processes which are taking place and how these processes are affecting the remote sensing, image acquisition as well as the analysis part. So let us begin with this lecture. This is a very popular diagram when we explain how the energy is travelling from the sun when we are talking about the passive remote sensing systems. So here when the sun is energy is travelling from the source to the object, there are clouds in between, atmosphere playing very important role. And in the atmosphere there are processes which are taking place like absorption, scattering process which is taking place, and the transmission. The remaining energy is transmitted to the ground. So we can see that when it strikes the object, the earth surface, various objects which are present on the earth surface, then the scattering process, absorption process, transmission process and reflection process, these all will take place. So we here are more concerned about the reflected energy because this is captured by the sensor on board the satellites, but we should know what is the impact of the other processes which have taken place before the reflection. And another important thing is when this reflected energy is travelling from object to the sensor, again those processes, scattering process, absorption process, they are again taking place in the atmosphere. So two processes are taking place, two times the processes are taking place in the atmosphere. And also the sensor is recording the emitted energy because every object at some temperature will emit the energy. So all the objects will emit their own energy and then it will also reach to the sensor. So there are two types of energy which will be captured by the sensor here. One is the reflected energy and another is the emitted energy by the object. If we look at the light which is interacting with the matter, so you can see here that there is a incoming light, sunlight, and then incoming sunlight is actually divided into the, if you pass through the prism, we know that you will get the different colors, RGB colors, and you will get some refraction process, reflecting process, scattering process. So very popular equation which we have given in our previous lecture also, the 100% of incoming light, that is a combination of various processes, and if we define these processes in terms of some terms, T plus R plus A plus S, which is transmitted energy, reflected energy, absorbed energy and the scattered energy. So this is all the mathematical equation is. Now we see various colors in the nature, and these colors are due to these, some of these processes which I have just now mentioned. You can see a rainbow in the sky, the reflection and transmission which is taking place. You can see due to the scattering and absorption, the blue color of the sky or the reddish color of the sky during the clear weather condition and sunset or sunrise respectively. Due to the absorption and transmission also you can see various colors of the rocks and the minerals. So in the nature what we see those different colors, we see because of these processes which are taking place in the atmosphere or with the object when this ray travels from sun to our eye or maybe to the sensor. Now there are several colors which are natural, there are several colors which are man-made objects. So we assign the colors to those different man-made objects, and they are also recognized by our eye because the reflection is reaching to our eye. So you can see because of the absorption phenomena or reflection phenomena, or could be absorption and emission by the traffic light, absorption and reflection by the coin, absorption and scattering by the paint, different kind of paints are there, the face mask. So you find that even the man-made objects are actually having that processes, suffer with those processes, and because of that we can see the texture and we can see the color of the objects. So these processes in the atmosphere are playing very important role. We have to understand each and every process. So here again this source of energy is there which is traveling. So we will understand absorption, we will understand here the scattering process which is taking place due to the presence of the molecules, the gas, the dust particle, the vapor particle, the ozone layer, or the cloud patches. So here on the cloud patch the scattering is taking place, and finally on the surface of the earth because of the physical and chemical properties of the object, because of the texture of the object, the scattering is taking place. The part of it is absorbed by the object itself. So temperature of the object sometimes changes because it is absorbing the energy, and then the sensor which is capturing the remaining part, which is the reflected part and also the emitted part of the energy. So one by one let us take all this. Absorption, what is that? It is the process by which radiant energy is absorbed and converted into the other forms of the energy. So any object will absorb the energy and it will convert into the different forms of the energy. Let us take the example of the iron piece. If you keep the iron piece in the sun for a while, you will find that it has absorbed the energy and its temperature has risen. So that means due to the rise in temperature, it has converted that energy into some other form of the energy. The absorption of the incident radiant energy may take place at two places, one in the atmosphere and another on the earth surface, different objects. Now this absorption, why it is taking place? Absorption is taking place due to the presence of many gases. It could be ozone, it could be carbon dioxide or the water vapor particles. These are the three major constituents which are present in the atmosphere and they will absorb the radiations. And that is a good thing that these molecules, these particles are absorbing the harmful rays. For example, the ozone will absorb the ultraviolet radiation, because these ultraviolet radiations are quite harmful to our body if we are exposed for a longer time. So we need protection from this ultraviolet, and ozone layer is automatically doing that work for us. So ozone layer is absorbing the harmful rays which is travelling from the sun to the earth surface, and without we are getting the radiation on the earth surface without much of the ultraviolet radiation, because of this is harmful if we get in the large quantity. Now there are carbon dioxides and they refer to as the greenhouse gas in the environment. So carbon dioxide gas is there and it is absorbing in the far infrared, thermal infrared part of the spectrum. So we have to capture the images in the thermal infrared part using a different concept altogether. Then we have the water vapor particles which are present in the atmosphere. They are also absorbing the thermal infrared and short wave microwave radiations. So these water vapors particles are present in the lower atmosphere, and this amount of water vapor particle present, it varies from location to location and different times of the year, varies from different times of the year, season to season. But this is also playing very important role because it is absorbing those thermal infrared long waves and the short wave microwave radiation. So these three important gases and water vapor particles are playing very important role. Just see in this diagram here. In this diagram on x axis we are showing the different wavelength region, and on the y we are showing the percentage absorption. So, here in this diagram we have shown the methane on the top, CH4, then oxygen and ozone, carbon dioxide, water vapor particle. So, if we see in which particular wavelength region the absorption is more, we can see that prior to ultraviolet region and after that ultraviolet region the absorption is maximum. So, we can see the peaks of the curves, different peaks of the curve. So, what is happening is that the visible part of the spectrum is the best part where absorption is minimum. So, this particular part of the visible part of the wavelength region we can probably utilize to design our sensor, because here the absorption will be less, and when the absorption is less the reflectance would be more. So, this is the concept actually which we are using in designing different kind of these sensors. So, this curve is very important to us in order to find out which are those useful wavelength region where absorption is minimum. So, this is the atmospheric absorption spectrum. We can see that here the completely absorbed. So, this is the reason where this is completely absorbed, this is the reason also again where completely absorbed, and then finally the other region where it is completely absorbed. So, ozone and molecular, oxygen, water and carbon dioxide and the charged particles, they are absorbing those radiations which are not required, and the visible part of the spectrum is completely transmitted through the atmosphere. And there are intermediate also, there are intermediate in infrared part, then in microwave window parts also there are intermediate windows, small windows where you can see the white color, where that means the transmission here is good and absorption is minimum. So, absorption of ultraviolet by ozone in the upper atmosphere and very little absorption in the visible part of the wavelength, that what we see is absorption of infrared and greenhouse gases in the lower atmosphere. So, that is what we conclude from this curve also. The second process is the reflection process, and it is the process when the radiations bounces off the object. So, radiation is striking to the object and it is bouncing from the object, and that process is called the reflection. So, it could be a top of the cloud or any feature, a water body or any object on the earth surface. So, striking, incoming, and then the outgoing is the reflection from the object. Now, reflection has a certain fundamental characteristics, and we know the Snell's law, and this diagram shows that this is the mirror here, and on the top of the surface of the mirror there is an incident ray, there is a reflected ray, and from the normal they are making equal angle. So, angle of incidence is equal to the angle of reflection. So, this is the Snell's law which ideal body like mirror should follow, but what is happening is because of the roughness of the surface, because of the constituents, the process is slightly different, which we have to understand. The incident radiation, the reflected radiation and the vertical, they are measured in the same plane, they lie in the same plane and they are making the equal angle. But here the surface is not as smooth as the mirror. We have taken the case of the mirror here, but in reality we have different kind of objects which are present on the surface. So, the considerable amount of energy which is incident radiant energy from the sun and reflected back either from the clouds or from the upper material of the atmosphere has absorbed or scattered or transmitted, and this diagram shows that if 100% of the solar energy traveled from the source, then reflected by the atmosphere will be 6%. It will be reflected by the atmosphere before reaching to the ground. Reflected by the clouds will be 20% again before reaching to the ground. So, all the clouds will be reflected it back. From the object reflected from the earth's surface will be 4% of that energy. So you can see here that what are the different kind of losses we would say, because reflection, if you want 100% reflection, then these are all the losses. So the only a small percent of the reflected energy now is captured by the sensor. Now third process, very important process, is scattering. So this is a very serious effect on the atmosphere. Scattering of the radiations by the atmospheric particles. So these are the atmospheric particles in the atmosphere, and this is the sunlight. When it is travelling and striking to those particles, the scattering will take place in all directions, multi directions the scattering will take place. So if we consider now, on one hand is the reflection and another hand is the scattering. So reflection is the incident ray striking to the object and reflected back, but what is happening is that in addition to the reflection, the scattering is also taking place on the surface of the earth. So these two are different now. Reflectance differs from the scattering part, as the direction of the reflectance is fixed according to the Snell law, the eye angle. Okay, but scattering could be unpredictable and it can go in any direction. So this is unpredictable. So this is shown here that in different directions the scattering is taking place. So this is also called the diffused reflection, the scattering which is taking place in all the directions. We do not know the angle which is made from the normal, then it is called the diffuse reflection, but where the direction is defined, the incident angle is equal to the reflected angle, then this is the reflected. Now we will focus little more on the scattering part. When particles or large gas molecules which are present in the atmosphere, they interact with the electromagnetic radiation, the scattering process will take place, and it will depend upon several factors and several parameters, including the wavelength of the radiation. So if we are working in a particular wavelength region of electromagnetic spectrum, the scattering magnitude of the scattering would differ. It also depends upon the diameter of the particle, the size of the particle or gases which are present in the atmosphere, and also the distance that the radiation is travelling from the sun to the atmosphere or to the object. So it depends upon three things: the distance, the wavelength region, and the diameter of the particles which are present in the atmosphere. Now we observe that short wavelength of visible light are scattered more effectively than the longer wavelength. So shorter wavelength means ultraviolet kind of a wavelength region are scattered more as compared to the longer wavelength, and because they scattered more, we can see the blue color of the sky in the morning, although the sky is colorless, because but the blue part of the spectrum is scattering more in the atmosphere. We can see the blue color, and orange and red color we can see when the sun is at a distance. It is not overhead, it is travelling a longer distance. When it is overhead, it is travelling the shortest distance. So we can see the blue color of the sky when the distance is less, and when the distance is more, then the longer wavelengths are scattering more, red and orange. And because of that, during our sunrise and sunset phenomena, we can see the color of the sky as reddish or orange color, although it is again the colorless, because the scattering is taking place. So the sun appears reddish in color because the blue light cannot reach the observer of the eye. The distance which is travelled when it is at the sunrise and sunset, the distance travelled to the eye is much more as compared to the overhead. So because of these two processes which we have seen, the color of the sky would appear blue, or it will appear as the reddish, the orange color. Now this is that scattering process which is shown here. During the sunrise the distance travelled is long, and during the midday the distance travelled is short, and because of that we can see the blue color distance, short distance travel, and due to the longer distance travel we can see orange and the reddish color of the sky. So during the daytime the blue part of the spectrum will scattered more and blue part will be lost because of the distance travelled. So red part will reach to our eye during sunset and sunrise. Now if we define the scattering into the different types according to the wavelength, according to the diameter of the particle, there are two broad categories of the scattering. One is the selective scattering and another is non-selective scattering. Under selective scattering, again there are two categories, relay scattering and the Mie scattering, and all these scattering will again depend upon the size of the particle, diameter particles which are present in the atmosphere. Let us see one by one them. This is a combined diagram which shows wavelength on the x axis and the scattering probability on y axis, and it shows that the maximum scattering basically is taking place, which is the shadowed zone here, and below that is the relay scattering, and the horizontal line here is indicating the non-selective scattering. So this is the Mie scattering region, this curve is indicating the relay scattering region, and the top horizontal line is showing the non-selective region. So let us understand the relationship now between the wavelength and the type of scattering which is taking place. So first one is the relay scattering. Now it is also known as the molecular scattering, and when it happens, when the effective diameter of the matter, which are usually the air molecules, oxygen or nitrogen which are present in the atmosphere, the size is much smaller, many times smaller. So 0.1 times, 1/10 of the size than the wavelength of the incident electromagnetic radiation, because the wavelength also we are defining in terms of the unit distance. So when we know the wavelength and the particle size is 1/10 or smaller than that, then the scattering which takes place is called the relay scattering, or in other words we can relate the two. We can relate the amount of scattering inversely proportional to the fourth power of the wavelength. So amount of scattering is related to the fourth power of the wavelength. So that is the relationship which exists. Now ultraviolet light, if you see the wavelength region approximately 0.3 micrometer region, so it is approximately now scattering 16 times more with that relationship as compared to the red part of the electromagnetic spectrum, 0.6 micrometer. So if we look at the previous relationship, put the wavelength value, so we can see that the ultraviolet light is reflecting 16 times more than the red light part, and that is why we see the blue color of the sky, because of the scattering is more. Most relay scattering is taking place in the upper atmosphere. Upper atmosphere is 4.5 kilometer above the equator. It is responsible for the blue appearance of the sky because of the more and more scattering which is taking place. Now violet and the blue part of the wavelength are more efficiently scattered as compared to the green and the red wavelength part, and that is why we are able to see the color of the sky. Now most remote sensing systems, the sensor systems, they avoid detecting the wavelength in ultraviolet and blue part of the spectrum, because if the scattering is more, probably the object will not be clearly visible from that kind of an image. So most of the sensors, they are not designed in remote sensing to work in these part of the spectrum. Now, if we look at the diagram here, the wavelength which is drawn on x axis and the percentage of light which is scattered is shown on the y axis, and if we define the wavelength in terms of their colors, then you can see the blue part is maximum scattered in the lower portion of the wavelength. So, we would design the sensors which would operate in this part of the wavelength region where scattering is less. Scattering is less, we assume that the reflectance will be more. The second category is the Mie scattering, and it is also popularly known as the non-molecular scattering. It is taking place in the lower atmosphere. The first one was taking place in the upper atmosphere, this is taking place in the lower atmosphere, which is below 4.5 kilometer above the equator. When the diameter of the particle which is present in the atmosphere, it is equal to the size of the wavelength of the energy. So, if we are working in a particular wavelength, let us say 0.4 to 0.5, so we are working in the wavelength region. So, what is that size? If the diameter of the particles are present of that size, then the scattering which take place in the atmosphere will be called Mie scattering, and the actual particle size may range from 0.1 to 10 times of the wavelength of the incident energy. So, here could be the dust particles or other particles which are present in the atmosphere which have this kind of a diameter. So, this scattering is taking place due to those particles which are dust, pollen, smoke and water vapor. So, this is the example of the particle size, and due to that particle size, the longer wavelength it will affect the slightly longer wavelength. So, mostly in the lower part of the atmosphere, due to the gas molecules, the relay scattering will take place. Due to the smoke and dust, the Mie scattering will take place. The third kind of a scattering is non-selective scattering, and this non-selective scattering is taking place in the lower part of the atmosphere, and the particle size is much bigger, usually 10 times or more the wavelength of the incident electromagnetic radiation, which is. So, if the particles which are heavier particles, which are bigger in size particle, if they interact with that electromagnetic radiation where the size is 10 times more than the wavelength, the scattering will be non-selective scattering. In fact, all wavelengths are scattered equally, and just not blue or green or red, as we have explained in the selective scattering part. So, here all wavelength will be scattered uniform, and that is why you have seen the horizontal line in the curve. And because the scattering is uniform of these blue, green and red color, and you know that when this is a uniform mixing of the color, what you get is the white. So, water droplets or ice crystals would appear to you as a white. Cloud, fogs, they all appear to you white color. Actually, they are colorless, and but because the non-selective scattering is taking place in all the wavelength of the light equally, and because of that, some objects appear as white to us. So, non-selective scattering is approximately equal portion of blue, green and red. If you mix up these colors, so what you get resultant is the white light. So, this is the concept to define the non-selective kind of a scattering. So, here is the cloud mass, and the particle size is much bigger than the wavelength which is used, and all the wavelength will be affected equally in this case, and that is why you can see that fog and clouds and mist would appear whiter in the shade. So, if we summarize now the process, relay scattering, Mie scattering and non-selective scattering, they are all wavelength dependent, but in different way. So, relay scattering is inversely proportional to the fourth power, while mile scattering is inversely proportional to the fourth power. Non-selective scattering is proportional to the wavelength. And what is the size of the particle? Particle size is 1/10. Here it may be 1/10 to 10 times, and it will be 10 times or more than the wavelength which we are using. So, very much dependent on the wavelength, very much dependent upon the particle size which are used, and also the distance which is travelled, and what are the kind of particles which are present in the atmosphere. The air molecules, because of that the relay scattering is present, the smoke, fumes and haze, because of that the Mie scattering is taking place, and because of the dust, fog and cloud the non-selective scattering is taking place. So, these scattering processes are also very important, because the reflectance will be low if the scattering is more. So, we have to now, considering the graph of absorption, considering the graph of scattering process, or by knowing the wavelength region where the absorption is minimum, where the scattering is minimum, we can probably select the ideal wavelength regions to design a sensor or to design a remote sensing system, so that it can collect the maximum reflectance from the object, and those objects appear much clear and much brighter on the image, and we can identify the image. So, these processes are helping us to understand the best wavelength region which we can use to design the remote sensing system. So, in a summary, the absorption and scattering are two major processes which are taking place in the atmosphere and also on the surface of the earth. So, these two processes are taking place on the different objects which are present. Now, atmosphere is playing a very great role, very big role for absorbing the harmful rays which are not required, which are unwanted. So, all the harmful rays will be absorbed by the atmosphere itself, the particles, dust particles or the ozone layer which is present there, and the best part is the visible part of the spectrum. So, we will find that the scattering is also minimum here, the absorption is also minimum. So, visible part is the part where our eye is also sensitive to this particular part. We can see those red, green and blue colors, and if we design the sensor in visible part of the spectrum and take those images, probably we can analyze those images with our eye. We do not require any instrumentation, we do not require any special gadget and devices to see those images. So, this is what we have learned in this topic. Thank you.